Hello, we are Lehigh University Space Initiative, Lehigh's competitive rover engineering team of 35 active members across 5 subteams. This year, we are excited to showcase our most robust rover yet, thanks to improved suspension modularity, streamlined ARM and science architecture, and custom electronics.
Fundamental changes in progress for LUSI's DCS subteam. We've switched to four wheels, two of which have highly maneuverable crab-style steer for dramatically improved turns and performance in tight spaces. We've switched from 3D printed and friction fit parts to a 100% metal, CNC machined and welded suspension that's far more durable for rough terrain. At the same time, our new design is much more adaptable and reconfigurable, in keeping with LUSI's philosophy of modular components. Switching out only 2 bolts, an operation that can be done in under a minute, allows the rover to switch between 8 different suspension modes, ranging from a low, stable configuration with a long wheelbase, ideal for robotic arm tasks, to a shorter wheelbase with high suspension travel and a superior breakover angle, ideal for difficult terrain.
At the heart of our rover is the NVIDIA Jetson Aura Nano, providing the endurance needed for extended mission cycles. This year, we designed custom power distribution boards, featuring a 12-volt power distribution board and a 5-volt step-down converter. The Jetson serves as our central hub, interfacing with secondary Raspberry Pis and our communication system via Ethernet. For autonomous navigation, we utilize GPS and IMU sensors, while a CAN bus interface bridges the primary computing with the driveline motor controllers. We also use an AirMax 2.4 GHz 13 decibel omnidirection antenna. The antenna provides high gain and reliable connection even when operating through obstacles and non-line of sight conditions. Power is supplied by a 12-volt 100 amp hour LiPo battery. The boards utilize XT60 connectors for quick disconnect modularity, streamlining assembly, and field debugging. We optimize the PCB layout with large polygon pores for proper heat dissipation and integrated fuses for each terminal. This custom design significantly reduced space and weight compared to previous years. Safety remains our top priority. The electronics are protected by a 120 amp circuit breaker in series with the battery and a readily available emergency stop button, which allows for an immediate cutoff of all rover systems.
Our software system primarily consists of ground station software, vehicle software, and additional subsystems to support every aspect of our design. Over the last couple of years, we've been working hard on fully adapting our C++ software environment to utilize ROS2 within Docker containers. These efforts have allowed us to easily integrate external libraries, modify our environment, and most importantly, quickly deploy and test software changes without any worry of operating system specifics. For the vehicle software, we have manual and autonomous drive and routing systems to allow for a flexible navigation. This year, to support the new drivetrain hardware model, we reworked our hardware interfaces for improved control, including the new steering system. As far as autonomous drive, we utilize cameras, GPS, and LiDAR to allow traversal to any coordinates or detected posts without any extra input from the operator. Our ground station software gives us a fully custom GUI environment to monitor every aspect of our rover live while controlling it. This allows for a smooth and intuitive, yet highly informed rover operating experience.
This year, our primary focus was on structural integrity and precision. Last year, we experienced a lot of vibrations due to a weak base. So this year, we redesigned and reinforced the base to eliminate vibrations at the source. This resulted in a much more stable and reliable system. From the bottom up, our base, shoulder, and elbow joints use Neo 1.1 motors, and our wrist joints use smaller Neo 550s. This gives us precise maneuvering with a 5 degrees of freedom system. The two main links of the arm are connected by 2x1-inch aluminum square tubing. Lastly, we upgraded the end effector. Our original 3D printed design began to show mechanical failure under load, so we redesigned the end effector using aluminum components and integrated a linear actuator to control the opening and closing of the claws. This change significantly improved strength, durability, and overall performance. These upgrades position our arm to deliver strong execution while remaining efficient and easy to operate.
Our science module uses specialized subsystems to analyze soil sites, collect a sample, and perform experiments to determine its potential to support microbial life. Built at half the footprint of last year's design, it delivers greater precision and capability across every stage of the mission. Wide-angle and close-up cameras alongside specialized software collect accurate geographic data to inform site selection and contextualize our results. A Neo 550 motor raises and lowers our collection platform, which uses vertically oriented support poles that maximize ground clearance. The auger deposits the material into our collection chamber, where a rotatable hatch discards surface soil above 10 centimeters depth, retaining only the subsurface material most likely to harbor microbial life. A 7-in-1 soil probe measures temperature, humidity, pH, and more within the collection chamber. The sample is then transferred to our testing chamber, where a load cell records sample mass. Our two chemical experiments target biological indicators directly. The Biuret test detects peptide bonds, confirming proteins produced by living or once living organisms. The Benedict's test detects reducing sugars, broadening our detection window for past biological activity. Both results are quantified using our custom-built spectrometer and lab-developed calibration curves. generating a data-driven hypothesis about the potential for microbial life in our sample.
LUSI is poised to succeed at this year's URC thanks to our increasingly modular rover design and functional improvements paired with significant systems testing. Thank you. See you in Utah.